cannabis plant consists of a wide variety of chemicals and compounds. About 140 of these belong to a large class of aromatic organic hydrocarbons known as terpenes, pronounced terpenes. You may have also heard people talk about terpenoids. The words terpene and terpenoid are increasingly used interchangeably, although these terms do have different meanings. The main difference between terpenes and terpenoids is that terpenes are hydrocarbons, meaning the only elements present are carbon and hydrogen, whereas terpenoids have been denatured by oxidation, drying and curing the flowers, or chemically modified. Terpenes are synthesized in cannabis in secretory cells inside glandular trichomes, and production is increased with light exposure. These terpenes are mostly found in high concentrations in unfertilized female cannabis flowers prior to senescence, the condition or process of deterioration with age. The essential oil is extracted from the plant material by steam distillation or vaporization. Many terpenes vaporize around the same temperature as THC, which boils at about 157 degrees Celsius, but some terpenes are more volatile than others. Terpenes also play an incredibly important role by providing the plant with natural protection from bacteria and fungus, insects and other environmental stresses. It is well established that cannabis is capable of affecting the mind, emotions and behavior. The main psychotropic cannabinoid, delta-9-tetrahydrocannabinol (THC), has been intensely studied. However, many of the other cannabinoids, terpenoids and flavonoids found in medical marijuana that play a big role in boosting the therapeutic effect of cannabis remain understudied. Terpenes are common constituents of flavorings and fragrances. Terpenes, unlike cannabinoids, are responsible for the aroma of cannabis. The FDA and other agencies have generally recognized terpenes as safe. Terpenes act on receptors and neurotransmitters. They are prone to combine with or dissolve in lipids or fats. They act as serotonin uptake inhibitors, similar to antidepressants like Prozac. They enhance norepinephrine activity, similar to tricyclic antidepressants like Elavil. They increase dopamine activity, and they augment GABA, the downer neurotransmitter that counters glutamate, the upper. However, more specific research is needed for improved accuracy in describing and predicting how terpenes in cannabis can be used medicinally to help treat specific ailments, health conditions. Synergistic effects. The Carlini et al. Study demonstrated that there may be potentiation, a form of synaptic plasticity that is known to be important for learning and memory, of the effects of THC by other substances present in cannabis. The double-blind study found that cannabis with equal or higher levels of CBD and CBN to THC induced effects 2 to 4 times greater than expected from THC content alone. The effects of smoking twice as much of a THC-only strain were no different than that of the placebo. This suggestion was reinforced by a study done by Wilkinson et al. To determine whether there is any advantage in using cannabis extracts compared with using isolated THC. A standardized cannabis extract of THC, CBD and CBN, SCE, another with pure THC, and also one with a THC-free extract, CBD, were tested on a mouse model of multiple sclerosis, MS, and a rat brain slice model of epilepsy. Scientists found that SCE inhibited spasticity in the MS model to a comparable level of THC alone, and caused a more rapid onset of muscle relaxation and a reduction in the time to maximum effect than the THC alone. The CBD caused no inhibition of spasticity. However, in the epilepsy model, SCE was a much more potent and again more rapidly acting anticonvulsant than isolated THC. However, in this model, the CBD also exhibited anticonvulsant activity. CBD did not inhibit seizures, nor did it modulate the activity of THC in this model. Therefore, as far as some actions of cannabis were concerned, e.g. antispasticity, THC was the active constituent, which might be modified by the presence of other components. However, for other effects, e.g. anticonvulsant properties, THC, although active, might not be necessary for the observed effect. Above all, these results demonstrated that not all of the therapeutic actions of cannabis herb is due to the THC content. Ethan Russo further supports this theory with scientific evidence by demonstrating that non-cannabinoid plant components such as terpenes serve as inhibitors to THC's intoxicating effects, thereby increasing THC's therapeutic index. This phytocannabinoid-terpenoid synergy, as Russo calls it, increases the potential of cannabis-based medicinal extracts to treat pain, inflammation, fungal and bacterial infections, depression, anxiety, addiction, epilepsy and even cancer. What are flavonoids? Flavonoids are one of the largest nutrient families known to scientists, and include over 6,000 already identified family members. About 20 of these compounds, including apigenin, quercetin, canflavin A and canflavin B, so far unique to cannabis, beta-sitosterol, vitexin, isovitexin, camphorol, luteolin and orientin have been identified in the cannabis plant. Flavonoids are known for their antioxidant and anti-inflammatory health benefits, as well as their contribution of vibrant color to the many of the foods we eat, the blue in blueberries or the red in raspberries. Some flavonoids extracted from the cannabis plant have been tested for pharmacological effects. The clinical findings are promising, but further research is needed to fully understand